So in this video, we're going to solve quadratic equations using completing the square. Now, there's a lot of instructions here about how to solve by completing the square. I think I'm going to go back to that after, or we'll look at it. I'm going to give you the steps as we go, so just a lot of words right now. We'll keep going. So again, when we come back to this slide now, after having done all the things, what you're going to notice is, again, these are the steps we followed. Keep a x and bx term on the left of the equal sign. Move the constant to the right. So that was our first step. Every time we move the number to the right side. Then we did the middle term, half of the middle term squared. We added that same term to the left and right to balance the equation. We factored our perfect square trinomial. And then we solved using the square root property. So everything they said, we did. Okay, so this, again, solved by completing the square. It's preferred, in my opinion, when A equals 1 and B is even. Okay, that's when I prefer it. Okay. The other method you're going to learn about, quadratic formula, that's the method I would do when A is not 1 or when B is not even. But again, you can do it when A is not equal to 1. It's not a problem. It's just a little harder. And you can also do it when B is odd. Again, you just have fractions. Okay, so when would you want to solve by completing the square? Well, first of all, you obviously want to try solving the easier ways first. So, solving by square roots that we learned yesterday, if the middle term is missing, obviously you're going to want to do it that way. We might want to factor something. If I see this and factoring is easy for me, I might say, okay, well, what numbers multiply to negative 14 and add up to negative 4? And I start thinking of factors of 14, and I realize it's 1 and 14 and 2 and 7. And none of them will give me a sum of negative 4. And so that's when I realize, okay, wait, I can't factor this. I can't solve by square root. So what do? Well, there's two methods that you can employ at that point when it's not factorable the other traditional ways. One is completing the square, and one is quadratic formula. We'll learn quadratic formula eventually. Today, we're going to learn to complete the square. And what happens is when completing the square, we're going to pay attention to this C value, okay? And what happens is that this C value isn't going to help us to factor. We realized that when we tried to do this, and we saw that there weren't any factors of negative 14 that equaled negative 4 when we added them. So what we're going to do is we're going to come up with our own C value. So we're going to take this C value and we're going to move it to the other side of the equation. So we're going to get x squared minus 4x equals 14. And now we see that we have like this open C value here. So we could do whatever, we can add in whatever C value we want, because remember, as long as I do it here to the left and I do it to the right as well, my equation will stay balanced. So my goal is to figure out some C value. Well, the formula is that you take half of the middle term. Okay, and then you take that half of the middle term and you square it. And that's going to give you the C value. So really the middle term, remember in a standard form of an equation, you get ax squared plus bx plus c equals 0. The middle term is the one with the x to the first power, and it's b. So half of b squared is really the new C value that we're going to get. So you look here at negative 4 and you say, okay, half of negative 4 is negative 2, and I'm going to square it. So if I add negative 2 squared to the left, I'm going to add negative 2 squared to the right. So when I rewrite this, I get x squared minus 4x plus 4 equals 14 plus 4. So what happens, now you're going to see why we did this. We'll now see that this x squared minus 4x plus 4 is really x minus 2 times x minus 2. And so this can be rewritten as x minus 2 squared equals 18. And notice now that we can do what we learned about with solving using square roots. If we take the square root of the left and the plus minus square root of the right, we can factor this. So we're going to get x minus 2 on the left equals positive or negative square root of 18. And if I add 2 to both sides, remember, keep it in the front, we're going to get 2 plus or minus the square root of 18. Now, I know the square root of 18 can be simplified to 9 times 2, and I know that the square root of 9 is 3. So there's a lot of steps there, but that's how we solve these problems. And that's how we come to our thing. So basically, in completing the square, you are creating your own C value. You're replacing the one that's there with your new C value. And that C value will now allow you to get this perfect square trinomial. It becomes a perfect square trinomial, which you can factor. So let's go to and try the next one. So again, over here, you initially, of course, unless I tell you to solve using completing the square, you're obviously going to try to factor first. And you do, okay, -1, the sum is 6, and you realize I can't do it. It's not factorable. It has a middle term, so I can't just solve by square roots. So this is a good candidate for completing the square. So again, I'm going to do x squared plus 6x, and I'm going to add 1 to both sides, that way getting rid of the 1 over there. I'm moving it to the right. So again, now I do plus half of 6, half of b, which is 3 squared. And I know that 3 squared is 9, so I'll just write it as 9 on the other side. And so again, we're going to rewrite it. X squared plus 6x plus 9 equals 10. And I know that now I made this perfect square trinomial. This is an x plus 3 squared equals 10. It's x plus 3 times x plus 3, and then I get x plus 3 squared. So again, then I'm going to do, just in case, maybe I don't want to skip a step just yet, let me just do this. This is an x plus 3 times x plus 3 equals 10, and then it's an x plus 3 squared equals 10. Okay, so now I take the square root of the left, positive and negative square root of the right, and I get x plus 3 equals plus minus square root of 10, and then I subtract 3 from both sides. So x equals -3 plus or minus radical 10. And if you notice, look at these answers. These were not answers that I would have been able to factor. Okay, so obviously these were not factorable any other way. When I get to number 3, I'm going to do the same thing again. So let me start again here. Let me go and do, again, obviously I'm going to try factoring traditional way. Product give me of -5, sum of 2 or positive 2. Guess what? There is no factor. Can't do it. So now I'm going to do completing the square. So x squared plus 2x, and I'm going to move the 5 over. So it equals positive 5. Okay? Then I know that I'm going to take half of 2x, which is 1, and I'm going to square it. Equals 5 plus 1. And then I'm going to come over to here and I'll rewrite it. X squared plus 2x plus 1 equals 6. And I know that this is x plus 1 times x plus 1 equals 6. So it's x plus 1 squared is 6. And again, now I take the square root of the left side and the plus minus root of the right side. And I get x plus 1 equals positive and negative square root of 6. So I'm going to subtract 1 from both sides, and I'm going to get x equals -1 plus or minus square root of 6. And there's your answer. And again, it wasn't factorable. Once you get these crazy answers with radicals, you know that it wasn't something that you could have factored in another way. Now, a shortcut to this would have been let's come back up here to this problem, let's say number 1. And once I knew that the half of b squared, right, I get this part, the -2 squared like that. Well, the half of b part without the squared, that's actually what's going in here into my little radicals. And that's what my x minus 2 squared is going to be. So technically, once I know that half of b is -2, I could write it like this because I want to remember to do -b squared over here. But I could really skip this step and this step, and I could just go straight from here to x minus 2. So it's going to be x, and then whatever this half of b is, that's the other number. So see here that half of b was 3. I know my factors are going to be x plus 3 squared. And notice it's there. I still have to do it on the other side because I got to remember to add that 9 or add this 4. But it does save me a little bit of work. So again, notice in this one, half of b is 1. So I know this is going to be x plus 1 squared. Again, I do the 1 squared there, but again, it saves you a little bit of time. I'll do it that way now moving forward. All right, so I'm going to keep going here. Now again, on this one, traditionally, I would probably try to factor this, right? And when I go to do this one, I'm going to notice that my product is 12, my sum is 7, and my factors are 4 and 3. So I know that this is a x plus 4 and an x minus 3. And so I know that x equals negative 4 and positive 3. So I don't really need to do completing the square here because this is factorable. However, let's just show you, I know my solutions are negative 4 and 3, but let's show you how this would work using completing the square. So I'm going to come over to here and I'm going to isolate my x squared and my 7x, and I'm going to move the 12 to the other side. Now I'm going to take half of 7. Now here the challenge is, this is an odd number. And when b is an odd number, you're going to get fractions in the mix. So for me, when b is a odd number, I sort of avoid completing the square. I do quadratic formula or something else just because, again, you're going to learn multiple methods and eventually you're going to pick your favorite. Some people, they don't mind fractions, and so they'll still do this method, but this makes it a little bit more complicated. When we do half of 7, I know that that's 3.5 or 3.5. However, we do everything as a improper fraction. So if I have half of 7, that's like multiplying a half times 7, so it's going to be 7 over 2. So I know that this value here is going to be 7 over 2 squared. So it's going to be plus 7 over 2 squared over here, okay? Now I can skip all this side here and I can go straight to what I was just telling you about and do x plus 7 over 2 squared on the left. Now on the right, I don't really have the luxury, right, of doing that. So here 7 over 2 squared is going to be 7 squared over 2 squared. And so that's what that side looks like. Now I've got to simplify this side, and I know that I got to give it a denominator of 4, which means I got to multiply the denominator by 4. So 1 times 4 is 4. So I have to do the same thing to my numerator. So this becomes negative 48. Okay? So now I'm going to kind of rewrite this side as the square root of x plus 7 over 2 squared, like that, equals the square root of negative 48 plus 49 is 1 over 4, okay? And again, this is going to be plus minus. So I just combine those to equal 1/4. So now the left side is going to be x plus 7 over 2, and the right side is going to be plus minus. Now the square root of 1 over 4 is the square root of 1 over the square root of 4, 2. And so the last step is to subtract 7 over 2, so it cancels on the left, and I do that. So let me kind of move it over to here. Now I've got x on the left, and I have negative 7 over 2 plus or minus a half. Now here you can leave it like this if you want, or you can expand it out. Negative 7 half plus a half is negative 6 over 2, which equals negative 3. All right, and negative 7 over 2 minus a half equals negative 8 over 2, which equals negative 4. And so, yes, those are the correct answers, and I just realized that from the very beginning here, my factors were x plus 4 and x plus 3. And so my solution should have been negative 4 and negative 3. I'm not sure if I got that and I transposed it wrong or I got it wrong. So just go back but it's minus 4 minus 3, and actually I got it right this time. Okay, so I'm going to erase these to give me room, but I want to make sure you have time to look at it before I erase it. Okay. So we'll go on to the next one. And so again, over here, number 5, we're in the same boat. This may or may not be factorable, but today we're completing the square, so we're just going to assume it's not factorable. So we move the 6 over, right? Now I'm going to take half of negative 3, and I'm going to square it. So this is going to be plus half of negative 3 squared. So I know this is going to transfer to x minus 3 half squared, and this side is going to needs a little bit of work, right? So I've got 6 over 1 plus, and this is going to be 9 over 4. So if I'm going to change this to 4, I'm going to change this to 24. So this here is going to be 33 over 4, right? So now I'm going to take the square root of the left and the plus minus square root of this other side. So it's going to leave me with x minus 3 over 2 on the left, and on the right, it's going to leave me with plus minus radical 33 over 2. And so I'm going to add 3 half to both sides, and I'm going to get x equals 3 over 2 plus or minus square root of 33 over 2. And this would be an acceptable answer, or you could do x equals 3 plus square root of 33, or plus minus rather, over 2 like that, and combine it. Either way is fine. Okay? So if you notice in all of these, we had the x squared, the a value was 1 in all of these, even on the previous page. What changed from the previous page or slide to this one was that the b's were odd in this slide, but a was still 1. Well, for completing the square to actually be able to be utilized, a has to be 1. B can be even or odd. It just makes it easier or harder. But a must be 1 to be able to do it. So I cannot go to number 6 and just say, oh, what's half of 12 and start completing the square. I can't do it. I have to have an a value of 1. And so what I am forced to do here is every single time that a is anything other than 1 is divide everything by a, okay? And so what that's going to do is it's going to make a 1, notice. Now, yeah, I'm going to end up with 12 over 9x, which is 4/3 x, and I'm going to end up with a minus 1/9 and a 0. So this makes it, again, look yucky. So again, for me, when b is odd or when a is not equal to 1, I actually choose to do completing the square, to do quadratic formula. I avoid completing the square with these. However, we have to know how to do it, okay? So I'm gonna, now that I have an a of that, of 1, I'm gonna do x squared minus 4/3 x, and I'm gonna move the negative 1/9 over to the other side. So that's the same process. I'm still gonna take half of negative 4/3 and square it. So negative 4/3 times a half is equal to negative 4/6, which is negative 2/3. So this is going to be plus negative 2/3 squared, and this is plus negative 2/3 squared. So again, knowing my shortcut here, I know this is going to be x minus 2/3 squared, and this side over here is going to be 1/9 plus 4/9. And so I know that this is going to end up being 10/9. So I'm going to take the square root of the left side and the plus minus, well, let me do it over here, plus minus square root of the right side. And so let me kind of work it out over here. I'm going to get x minus 2/3 equals, and I'm going to get plus minus square root of 10 over 3. And then I add 2/3 to both sides. So again, your answer here is going to be x equals 2/3 plus or minus square root of 10 over 3, which is acceptable, or you can do 2 plus or minus square root of 10 over 3 like that. And so that's the answer. So again, a little bit more complex, a little bit more stuff to do, but not terribly difficult. Let me see if I can do this. Move this over to here. Okay, that actually worked well. Okay, and then we'll go to our last step here, our last one. Let me do it in a different color. So again, we've got this 3 here in front, and I can't have it, so I divide everything by 3. That's going to make my x squared plus 2/3 x minus 5/3 equals 0. Again, I'm going to move this 5/3 over. So x squared plus 2/3 x equals positive 5/3. Now I'm going to take half of 2/3, which is going to be 2/6, which is 1/3. So this is going to be plus 1/3 squared plus 1/3 squared. So this side here is going to be x plus 1/3 squared equals, and it's going to be 5/3 plus 1/9, which is going to be, I have to change my denominators, so times 3 is 9, times 3 is 15, so I'm going to get 16/9, like that. And then I take the square root of the left and the plus minus square root of the right. My left side becomes x plus 1/3. My right side becomes plus minus, square root of 16 is 4, square root of 9 is 3. And so I'm going to subtract 1/3 from both sides. And so I'm going to get x equals negative 1/3 plus or minus 4/3. And again, you could stop right there if you wanted, or just finish it through. So if I do negative 1/3 plus 4/3, I get 3/3, which is 1. And if I do negative 1/3 minus 4/3, I get minus 5/3. So I have two solutions here. I have x is 1 and negative 5/3. So I could go with that, or I could go with that, okay? And again, if my answers look like this without any radicals, I know that I could have factored this a more traditional way. However, again, this works for everything. We'll get to the last three problems. Same thing, that's just a little bit more complex because you have some where you have odd b's and some where you have a values, or all of them have a values other than 1. So just a little bit more difficult, but same strategy. So let's start out again by dividing everything by 3, because again, the a value has to be 1. So x squared minus 4/3 x minus 1/3 equals 0. So I'm going to move this over. So I'm going to get x squared minus 4/3 x equals positive 1/3. Now I'm going to do half of 4/3 is 4/6, which is 2/3. So it's going to be plus minus 2/3 squared. Notice again, if this is a minus here, then this is going to be a minus in there, okay? And then over here, I'm going to have plus minus 2/3 squared. So this is going to change or become x minus 2/3 squared, and it's going to equal 1/3 plus, and minus 2/3 squared is 4/9. So this is going to change to a 9, which means this is a 3, and I'm going to get 7/9 here. So I'm going to get x minus 2/3 squared equals 7/9. Square root plus minus square root. I'm going to get x minus 2/3 equals plus minus square root of 7/3. And then I'm going to add 2/3 to both sides. So 2/3 plus or minus square root of 7/3, which is acceptable, or x equals 2 plus radical 7, or 2 plus or minus radical 7/3. Same thing. Okay, we keep going. We go to number 9. Again, we're going to move the 1 over to the other side. So 5x squared. Oh, no, wait. Sorry, my bad. We're going to get rid of this 5. We have no choice but to do that. So we start out with that. So x squared minus 7x/5 equals 1/5, right? So now I'm going to take half of 7/5, which is 7/10. So it's going to be plus minus 7/10 squared plus minus 7/10 squared. So I'm going to get x minus 7/10 squared over here on the left. And on the right, I'm going to get 1/5 plus, and this is 49 over 100. So if I make this 100, that's times 20, so this is going to be 20. And so this over here is going to end up being 69 over 100. So I've got x minus 7/10 squared equals 69 over 100. I'm going to take square root of the left, positive and negative square root of the right. And I'm going to get x minus 7/10 equals plus minus square root of 69 over 10. Add 7/10 to both sides. And we get x equals 7/10 plus or minus the square root of 69 over 10. Or you can do 7 plus or minus square root of 69 all over 10. All of this is the same, okay? And so we're down to our last problem. So let's get to it, right? Here we've got a -1. And again, we cannot have, even a -1 is not acceptable. So I'm going to divide everything by -1. So that's going to leave me with x squared minus 3x minus 5 equals 0. I'm going to move the minus 5 over, so x squared minus 3x equals 5. Again, I'm going to do half of 3, which is minus 3 over 2 squared. So this is plus minus 3 over 2 squared. This side becomes x minus 3 over 2 and the whole thing squared. This side over here becomes 5 over 1 plus, and it's going to be 9 over 4. So if I want to change this to a 4, I'm going to have to change this to a 20. Okay, so this side here is going to be 29 over 4. So I've got x minus 3 over 2 squared equals 29 over 4. Square root. And so we've got x minus 3 over 2, x minus 3 over 2 equals plus or minus the square root of 29 over 2, and I add 3/2 to both sides. So x is 3/2 plus or minus the square root of 29 over 2. That's an acceptable answer, or I can just combine my numerators on the top and just have one denominator like that. This is a cleaner answer, but again, I'll take either. And that's how you do it. So that's all the examples.